Okay, hello everyone. In this tutorial about solve differential equation in Python. To solve any differential equation, I use the Scipy.integrate package, and especially I use the ODEINT. The ODEINT we have three arguments. The first one is called the model. The model is our function name. I use the diff to define this function. This function is return derivative values at request y and t. The second one is y0 is initial condition at the differential state, and the last argument is t, the time points at which solution should be reported. Here we have the example derivative for y by derivative y by dt equal to minus k for and multiplied by t. Example here, k is equal to 0, 3 and t in the time. And the final result, we need to get this profile. Okay, we have this. We have not okay. Just open one. I have to get this profile. Okay. In the x-axis we have time, and y-axis we have the y, our function, and we need to get example. Okay, can see example this profile example. So let's start with the first script. So first, why we have to use the Scipy. Okay, let's open our program. So in first step, you need to install Piezo. It's very simple, and you can use all the package. You don't need to install one by one. I use cmd command. So if you install the Piezo, you get all all the package like cp, like matplotlib, and numpy. Okay, the first command is to import cep as eTwar or ASP after from cep.integrate import ODEINT or import ODEINT. Yes. After import matplotlib .pplot as plt. This command we use to plot the graph. Here because we have the differential equation, so we need to call the cp.integrate and ODEINT. This is the principal command for cp package. Okay, let's start with the first step is to define the function. This here just the you cannot, if you want to add any command, just use this symbol, define function. To define any function in Python, I use def. Example, we have deriv. Let's go back to our example. Here we must in first range to use any differential equation in the first range, and the second range is defined to y and the t parameter in the second range. Deriv and as parameter we have the time and the y, and the return minus p, we have 0, 3 multiplied by t. Second step is to define x-axis. The x-axis is like time, okay, time or t, okay. We should provide t0 is initial time. Example, we have 0. Can I use the command? The command is the initial time is 0 second. T final is 10 is time final time final final time is 10 second, and the number of the point, for example, in point equal to like 100, and we should draw the t or define the time axis. I use t equal to esp point length space, and as parameter we have the initial time t0, the final time tf, and the number of point is in point, or number of division between 0 and 10. And the second step, we should provide the solution of equations. First we should have y0 is 5, okay. Y0 is 5. Example, we have the solution equal to ODEINT. We have as parameter we have the we have model is deriv y0 and time. Deriv is function, okay, y0 at equal to 0 and the time. After simple, we provide y-axis is here t and y. Y is dependent the solution, but we should provide this at any okay, at 0. That is mean the degrees of this equation. For example, if you have y, the order of derivation. For example, if we have the first, I use 0. If you have y and y and the second order of derivation, we have 1. Example, if we have third order is 2. And we should draw the graph. It's very simple. Is a plot graph. We use plt one plot. The first argument is time and the second argument is the y. And to show the graph, before we need to rename the x-axis and the y-axis. For x-axis, we should use plt one x label. Example, we have the time, and at y-axis is plt one y label. We have y, okay. And to show the graph, I use plt point show. We need to save it. This script, example, equation diff 1, and running. I use go to execute selection. In the final, after running the program, can again we have to run and we get this profile. So let's check. For example, for y equal to 0, we have the time as is already defined. and any time we have the profile of y. So as you see, the Python is can resolve okay, the any differential equation. Okay, in the next video we will see an example of vibration analysis for discrete system. The objective so is to the plot or to see what is the response of the system, like acceleration, velocity, and displacement in function of course of the time. Okay, thank you very much. If you have any question regarding this video or the previous tutorial, you can just contact me on my YouTube on my Gmail. You can just comment in this video, and please not forget to subscribe my YouTube channel to receive the news. And thank you.